Hello students, welcome to the another session of this differentiability. In this session we will be studying derivatives of functions in parametric form. So first let me tell you what do you mean by parametric form and what do you mean by parameter. So parameter means it is a third variable you can say. So parameter andre it is third variable. It can be t, it can be theta, it can be r, so anything apart from two given variables. So parametric form antandre you will be given two expressions. Here a parametric form means a relation expressed between two variables x and y in the form x is equal to f of t, y is equal to g of t is said to be parametric form. Antandre ಏನಾಗಿರುತ್ತೆ ಅಂತಂದ್ರೆ basically one relation ಯಾವುದು ಇರುತ್ತೆ in terms of x and y. So ಅದನ್ನೇ you can express in terms of third variable t or theta. For example, see here x is equal to f of t, y is equal to g of t. ಈ ತರ ಇದ್ರೆ ಆ ಫಂಕ್ಷನ್ ಅನ್ನ ಪ್ಯಾರಾಮೆಟ್ರಿಕ್ ಫಾರ್ಮ್ ಅಂತ ಕರೀತಾರೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಇದು ನೀವು if you look at this x square plus y square is equal to a square. Okay, so what is this? This is equation of circle with center at origin and radius e. For example, see here, actually this represents this equation gives you, or it represents the family of circles with center at origin. Center is at origin and radius is a. Okay, so radius is a and center is at origin. So equation of this circle or this equation x square plus y square is equal to a square. So ಇದನ್ನೇ ನಾವು ಇದೇ equation ಅನ್ನ you can express in terms of parametric form. Means if I take x is equal to a cos theta, here theta is new variable, new parameter you can say, and y is equal to a sin theta. Okay, so this pair or this function represents circle. ಯಾಕಂತಂದ್ರೆ it satisfies that equation. ನೀವೇನಾದ್ರೂ if you square and add, what will you get? X square plus y square is equal to a square common, and you will get cos square theta plus sin square theta, which is 1. Okay, so this is 1. So you will get x square plus y square equals to a square. This is your Cartesian form and this we call the parametric. So sometimes it is essential to convert Cartesian into parametric form. So in that case we go for parametric equation or parametric functions. Okay, so ee tara navu if x and y are in terms of some t or r or theta, then such functions are called parametric functions. Okay, so inth type iddaga how you can find derivative. Okay, so basically ಇಲ್ಲಿ ಏನಂತಂದ್ರೆ we use the chain rule format. Now see here, so the chain rule, we know that chain rule. So we can write by using chain rule. dy by dt can be written as dy by dx into dx by dt. This can be written as just multiplying divide by dx by dx. Okay, so this, and we want this dy by dx. If you want dy by dx, so this implies, okay, so this dy by dx. So dy by dx is equals to, okay, bring this down. So you will get dy by dt by, so dx by dt. So remember that if you are given, so remember this, you can find dy by dx using this formula, dy by dt by dx by dt, if x is function of t and y is some function of t. Okay, so if x and y are some functions of t, then you can find dy by dx. Suppose you have theta here, then you can write dy by d theta by dx by d theta. So let's have some examples on this, and again from the point of examination you will be getting one definite question on this. Okay, so write an example. Find dy by dx if x is equals to a cos theta and y is equal to a sin theta. Actually this is equation parametric form of circle. Okay, so when you go for higher studies you will get that. So here x and y, they are in terms of theta, so you can write the formula dy by dx is, it is dy by d theta dx by d theta. Okay, so remember this. Now you have to find what is dx by d theta and dy by d theta. One can do directly. So now you have y is equal to a sin theta. So you have to differentiate with respect to theta, not with respect to x, because we want dy by d theta. So dy by d theta is equals to a constant and derivative of sin theta is cos theta with respect to theta. Okay, so similarly you have x is equal to a cos theta. Differentiate with respect to theta. Okay, so differentiate with respect to theta. So derivative of cos is minus sine, so I can write minus outside a sine theta. Okay, so now, so therefore we are interested in dy by dx, and which is dy by d theta by dx by d theta. Substitute, it is a cos theta here, and here it is minus a sine theta. So a cancels. So cos by sine is cot, and minus 1 is there also. So minus cot theta. So this is your dy by dx. Okay, very simple example I have taken. Okay. So please note down. Have one more example. Find dy by dx if x is equal to 8t square and y is equal to 2at. Okay. So in this case, okay, here x and y are in terms of t. So therefore, first write dy by dx is equals to dy by dt dx by dt. Okay, now you have to find the derivatives and substitute here. One can write directly if it is for 1 mark. Okay. So x is 80 square. Differentiate with respect to t because we want dx by dt here. So dx by dt is equals to a into, you are differentiating with respect to t. So like derivative of x square with respect to x is 2x. So similarly, derivative of t square with respect to t is 2t. So you can write it as 2at. Okay. So similarly, your y is 280. Okay, you are given y as 280. Differentiate with respect to t. So again, dy by dt is equals to 2a constant and derivative of t with respect to t is 1. Like how derivative of x with respect to x is 1. So in the same way, derivative of t with respect to is 1. So which is 2a. Okay. So now you can calculate this dy by dx we want. So which is dy by dt by dx by dt, and dy by dt is 2a here, and dx by dt is 2at. So simplify 2a to a cancels, 1 by t is the answer. Okay. So note down this. So I have one more example. Find dy by dx if x equals to a into theta plus sine theta and y equals to a into 1 minus cos theta. Okay. So as usual here x and y are in terms of theta. So what dy by dx will be? Better you write dy by d theta by dx by d theta. This you have to find. Okay. Now you have to find individual derivatives, that is dx by d theta and dy by d theta. So x is equal to a into theta plus sine theta okay. Differentiate with respect to theta. Okay, differentiate with respect to theta. So it is dx by d theta a into derivative of theta with respect to theta. Okay, so derivative of x with respect to x is 1. In the same form, derivative of theta with respect to theta is also 1. Carefully. Derivative of sine theta with respect to theta is cos theta. Okay. Similarly, y is equal to a into 1 minus cos theta you have. Okay. Differentiate with respect to theta dy by dx is equals to a constant as it is, 1 is constant, its derivative is 0, minus derivative of cos theta is minus sin theta. Remember this. Derivative of cos theta is minus sin theta. Now this minus into minus plus. So a into sin theta. So this is your dy by, sorry, here d theta. It is dy by d theta. Okay. Now we are interested in dy by dx. So which is dy by d theta by dx by d theta. So substitute whatever you had, a into 1 plus cos theta, sorry, dy by d theta is this. It is a sin theta by a into 1 plus cos theta. Okay. Cancel a, you will left with sin theta by 1 plus cos theta. Now further you can simplify it. Okay, it's a beautiful expression that reduces to one simplest form. So convert sin theta in terms of half angles. So sin theta can be written as 2 sin theta by 2 into cos theta by 2. Remember this. It comes often. So 1 plus cos, also very important. You have to remember this as well. So whenever you get 1 plus cos theta, remember this, write down. It is 2 cos square theta by 2. And if you get minus 1 minus cos theta as 2 sin square theta by 2. Better you make note of this as very important. Okay, so here 1 plus cos can be written as 2 cos square theta by 2. So 2 cancels and 1 cos term also cancels. So you left with sin theta by 2 by cos theta by 2, and that you may write it as tan theta by 2. So this is your dy by dx. Okay. So I will be doing some examples from exercise 5.6. So exercise 5.6. Okay, so we will do it in 2 sessions. So let me do few examples from this. So find dy by dx in all the cases. First one, x is equals to 2at square, and you are given y is equal to at power 4. Okay. So straightforward. Both are functions of t, so differentiate with respect to t. So this is being simple example, I am doing it directly. dx by dt ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ 2a ಹಾಗೆ ಇದೆ ಕಾನ್ಸ್ಟಂಟ್, and derivative of t square is 2t. Okay, with respect to t and l. So that gives you 4at. Similarly here, dy by dt is a as it is, and derivative of t power 4, derivative of x power 4 ಏನಾಗುತ್ತೆ with respect to x ಅಂದಾಗ 4x cube ಆಗುತ್ತೆ. ಹಾಗೆ here it is 4t cube. ಈ ಪವರ್ ಅನ್ನು ಮುಂದೆ ತರಬೇಕು, ಪವರ್ 1 ಕಡಿಮೆ ಮಾಡಬೇಕು. Okay, so this you may write it as 4at cube. So this is your dy by dt. So we are asked to find this. dy by dx is dy by dt by dx by dt. Substitute ಮಾಡಿ, ಇದು 4at power 4 divided by 4at. So ಏನು ಬರುತ್ತೆ, 4a cancels, ಒಂದು t cancel ಆಗುತ್ತೆ, so you left with just t. Okay, t square by t ಅಂದರೆ t also get cancels, so you will get just t. So we have one more example. Find dy by dx. In all the cases, you have to find dy by dx. So x is equal to a cos theta x is equal to a cos theta, y is equal to b cos theta. Very simple. here x and y are functions of theta. So differentiate with respect to theta. So dx by d theta is a constant and derivative of cos is minus sin theta. So you can write it as minus a sin theta. dy by d theta. B as it is, again derivative of cos is minus sin theta. You can write minus b sin theta. Okay. Therefore, dy by dx is dy by d theta by dx by d theta. So that is minus b sin theta. Okay, dy by d theta is minus b sin theta, and this is minus a sin theta. So minus minus cancels, sin cancels, you will left with b by a. So this is your dy by dx. Okay. Here is another example. Find dy by dx. Okay. You are given x is equals to sin t and y is equal to cos 2t. Okay. So, sorry, x equal to sin t. X equal to sin t, y is equal to cos 2t. So here x and y are functions of t. So differentiate with respect to t. Dx by dt equal to derivative of sin t with respect to t is directly can write cos t. Here ಇದರಲ್ಲಿ derivative of y with respect to t ಅಂದ್ರೆ cos derivative minus sin 2t. ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿರಬೇಕು ಇಲ್ಲಿ ನೋಡಿ, cos ಒಳಗಡೆ ಏನಿದೆ 2t ಇದೆ, ಅದರ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಬರಲಿಕ್ಕೆ ಮರಿಬಾರ್ದು. ಸೊ ಇಂಟು ಡಿ ಬೈ ಡಿ ಟಿ ಆಫ್ 2t. ಕೆಲವರು ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀತಾರೆ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀಬೇಕು. ಸೊ ಯಾರಿಗೆ ಗೊತ್ತಿಲ್ಲ ಅವ್ರು ನೋಡಿ, it is sin 2t and derivative of 2t with respect to t is 2 anta. So you can write minus 2 sin 2t. Actually cos ax derivative minus a sin ax ಅಂತನು ನೆನಪಿಟ್ಕೋಬೇಕು ನೀವು. Okay, so finally therefore dy by dx is equals to dy by dt by dx by dt which is equals to dy by dt we have here minus 2 sin 2t divided by cos t. Okay, ಸೊ ಇನ್ನು ನಿಮಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕು ಅಂತ ಇದ್ರೆ ಅಥವಾ ನಿಮ್ಮ ಟ್ಯಾಲೆಂಟ್ ಅನ್ನ ತೋರಿಸ್ಬೇಕಂತ ಇದ್ರೆ, ನಾನು ಹಿಂದೆ ಹೇಳಿದಂಗೆ ಈ ಸೈನ್ 2 ಥೀಟಾನ ಹಾಫ್ ಆಂಗಲ್ ಅಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಮಲ್ಟಿಪಲ್ ಆಂಗಲ್ ಅಲ್ಲಿ 2 sin t cos t ಆಗುತ್ತೆ. ಸೈನ್ 2 ಥೀಟಾ ಅಂದ್ರೆ 2 sin ಥೀಟಾ cos ಥೀಟಾ. ಅದಕ್ಕೆ ಸೈನ್ 2 ಥೀಟಾ 2t ಅನ್ನ 2 sin t cos t ಅಂತ ಬರೆದು ಡಿವೈಡೆಡ್ ಬೈ cos t ಹಾಗೆ ಇಡಿ. ಸೊ cos ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಬೇಕಾದ್ರೆ ನೀವು ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಇದನ್ನ. sin 2 ಥೀಟಾ ಇಸ್ 2 sin ಥೀಟಾ cos ಥೀಟಾ ಹಿಂದೆ ಬರ್ಸಿದ್ದೀನಿ ನಾನು. ಓಕೆ, ಸೊ ಅದನ್ನೇ ಬಳಸಿದೆ ಇಲ್ಲಿ. ಸೊ ವಾಟ್ ರಿಮೇನ್ಸ್ ಈಸ್ -4 into sin t. This is your dy by dx. Okay. So we have few more 2 examples I do in this session. Find dy by dx find dy by dx. So x is equals to, this is example 4, x is equals to 4t and y is equals to 4 by t. Okay, x and y are functions of t. So find dx by dt and dy by dt. So differentiate with respect to t. So dx by dt, 4 constant, derivative of t with respect to t is 1. So you can write directly 4. In this case, dy by dt is equals to 4 and derivative of 1 by t, derivative of 1 by x. Let me write, note down this, d by dx of 1 by x, derivative of 1 by x with respect to x is minus 1 by x square. Remember this. Okay. So in the same form, derivative of 1 by t is minus 1 by t square. Okay. So you can write it as minus 4 by t square. Okay, this is divided by dt. Okay, now substitute. So write this. Therefore, we are interested in dy by dx, which is dy by dt by dx by dt. Okay, we have minus 4 by t square whole divided by 4. So 4 cancels. You can write minus 1 by t square. Okay. So last one we will do in this session and remaining 6 examples in the next session. Okay. So find dy by dx. This is example number 5 of exercise 5.6. X is equals to cos theta minus cos 2 theta. Y is sin theta minus sin 2 theta. Okay, here x and y are functions of theta. So you have to differentiate with respect to theta. Okay. So what we will get? Dx by d theta is equal to derivative of cos is minus sin. Again derivative of cos is minus sin, so minus of minus it becomes plus sin 2 theta into derivative of 2 theta with respect to theta is 2. So you can write it as minus sine theta plus 2 sine 2 theta. Okay. So in the same way, dy by d theta is equal to derivative of sine theta is cos theta, derivative of sine 2 theta is, it is cos 2 theta into derivative of 2 theta is 2. So you can write it as cos theta minus 2 cos 2 theta. Okay. So this is how you can find dy by d theta and dx by d theta. Now dy by dx is, as usual, dy by d theta by dx by d theta, and you can substitute these values whatever you have, substitute it is cos theta minus 2 cos 2 theta divided by minus sine theta plus 2 sine 2 theta. Okay. So this is how we can find derivative of parametric functions. So in the next class we will be doing one more session on this. So there are almost 6 questions. So we will meet in the next session.